Okay. So, that very last problem, when I did it on my calculator, and I need everybody to type with me because something is happening, and I'm not sure what it is. So, the deal is we're gonna do one hand a second. So the number of possible hands would be 52C13. So I need everybody to do that on your calculator. 52C13. Okay? And we're not going to round that off or do anything else. It's just there. Now that is how many hands there are. So that is how many seconds there are. Right? So I'm going to go ahead and just hit divided by 60. And that will give me how many minutes. And then I'll go ahead and do divided by 60 again, and that will give me how many hours. I'm going to stop right there. What? Oh, look who's here.
Try, what's going on? All right. Little Precal. How's it going? How's it going? I'm bothered. I've got time to kill. I'm going to observe Waisaki at 11:45. Thought I was getting a laptop, but Jim wasn't quite ready for me. So I got to go back at 12:30. It's all right. It's all good.
You're retired.
I'm retired. I'm not a care in the world. Look, how's it going?
Well,
I'm going to
actually,
do that, but
we're trying to discover something here because.
Right, something I forgot to teach.
No. I think
Those
it's
are
something
directors.
with the
We never
new
got to talk.
calculators, and they're not either. They're doing something else
Okay.
in the last period. But we've got a calculator thing we're trying to figure out.
Yeah, all right.
So here we go.
Okay. I'll leave you alone. Good
Tell
job,
me
guys.
on
I'll be
your
back. Hold
screen
on
right
a minute.
now. I want one person to tell me somebody with a new calculator, like one of that kind right there. What does it say?
Like 17.
639.
639.
And then 0.4?
Yeah.
Okay, so we're saying exactly the same thing. All right, so now I'm going to go ahead and divide by 24. So do you have a number that says 0.977? And then I'm going to go ahead and divide by 365.
24 hours a day.
Okay, now what I got was 20,136.15.
Yeah.
Is that what everybody got? Then how in the heck did so many of you come up with that other thing?
Because when we did it in class, you said like, see this stuff times 10 to the 11th, and we thought you were saying like you multiply it by 10 to the 11th, not the answer is 10 to the 11th.
Oh, well, all right. I'm sorry about that confusion. This is the answer, right? So this is the correct answer. That is the correct answer.
Because I thought she said that she said it's 10 to the 11th, so that you raised it 10 to the 11th.
What I meant was that
The answer
there were
is
10 to the 11th way, something times 10 to the 11th ways.
Yeah.
That number on my calculator.
Because yeah, our answer is literally just like 3 more decimal places. Like if you move 0.
Well, I don't know, but my answer was right.
Yeah.
So what you just got on your calculator is correct, right? All right, we need to do a couple more questions from here, and then we need to move on. So one thing I want to talk about is in number 3, some of you are getting your combinations and permutations mixed up. Guys, those of you that said 3B was a combination are frankly crazy. In a phone number, in a telephone number, does the order of the numbers matter?
Yes. Very much.
Yes. We can both have the same numbers in our number, but it's all different depending on the order you put them in, right?
Yeah.
So problem B is clearly a permutation. Lucy.
Wait, can I ask about another problem or no?
I am still on number 3, okay? Maren?
About 3B, how would you write that as if, like, would that be 10P7?
Yep. Assuming any number can be anywhere, yes, 10 to 7. All right. Letter D. Now, I didn't tell you how many we were picking from. let's say we're gonna do a movie about the Beatles. And 50 actors show up to audition. All right, so you got 50 people showing up to audition to be the Beatles. I'm gonna pick 4. Does the order I pick those 4 matter? Yes, because somebody's gonna be Ringo and somebody's gonna be George, right?
I thought it was like a committee of 4 people.
No, it is not a committee because, and this is huge, listen. If I pick a committee of 4, then everybody has the same job. And the order I choose them doesn't matter. If I am, so, let's go back to my Beatles movie. I am picking 4 people to play the crowd, you know, the people out clapping in the audience. That would be 50C4, because everybody is the same. But if I am choosing a specific job, then it's gotta be P. And that's exactly the same thing. If I decide, okay, 28 of you, I'm gonna give away 4 prizes. If everybody's getting a blue marker, that's 28C4. But if somebody's getting a $100 bill, a $5 bill, my eraser, and my pencil, then it's 28P4, because it matters the order. Okay, we got it? All right, one more question. Lucy,
Can we do 6?
how many different 5-card hands contain both red aces? How many cards are in the deck? 52. How many of them are red aces? 2. How many of them are not red aces? 50. So essentially, I'm splitting my deck. I got 2 red aces here and 50 not red aces here. Now, how many cards are in my hand? I want a 5-card hand that has to have both of the red aces. So I'm taking both of these. 2C2. How many more cards do I need? 3, and where are they coming from? The cards that aren't red aces, so 50C3. So 2C2, absolutely, when you do things at the same time, this and this, you multiply.
Times 52C2?
2C2 times 50C3.
50.
You already pulled the red aces out. 50 left. All right, this is the last question. If you have more, you need to come to office hours. We gotta move on. Number 8. If a coin is tossed 8 times, how many times can one expect to get at least 7 heads? What does at least 7 heads mean? I could get 7 heads and 1 tail, or I could get 8 heads and no tails, right? That's what can happen. Okay, so how many coins am I flipping? 8, I need 8 coin tosses. So 7 heads would be 8 tosses, 7 of them heads, and 8 tosses, 1 of them tails. You gotta toss it 8 times. All right, and then, oh no, wait a second. No, that's not right, I'm sorry. Yes, you have to toss it 8 times, but I want 7 of them to be heads. Automatically, what's gonna happen to the other one? It's gonna be a tail. Or, I want all heads. So 8 tosses, all heads. Now, if I'm doing probability, I'm gonna have to deal with that tail, but I'm not doing probability here. I am just doing, how many options there are.
So when it's like saying at least something, is that when you add them together?
Anytime it can be this situation or this situation, I'm adding. Yep. Okay, now, we need to move on, guys, so we gotta finish up 9-2, solve it, and start 9-3.
Wait, what is this? Just the dashes? Like, there's like different marks on the paper. What do they mean?
Oh, there was, it's just on the paper, I had a copy of the sheet or something.
Oh no, like all the
Eight.
Okay, problem number 7, we need to get through this, problem number 7.
But is it just this? So you wrote that?
Guys, this is not the answer to the question. I do not know what these two things are, but they have to be added together on my calculator to get the actual answer to the question. Okay? Do not leave just the setup. Do not leave just the setup. You have to, work it out. All right, number 7. We are proving that this plus this adds up to this. Okay, so let's think back a minute. Let's think back a minute. What's our formula for this? N factorial over n minus 2 factorial, 2 factorial. So that is just the formula version of this. All right, what's the formula for this? N plus 1 factorial over n plus 1 minus 2 factorial, 2 factorial. So now we're going to start simplifying. Let's just start right here. What does n factorial mean? N minus 1, n minus 2, and dot, 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 in perpetuity. What does n minus 2 factorial mean? N minus 2, dot, 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 forever. N minus 3, n minus 4, so on. And then what's 2 factorial? 2 times 1, which is just 2, right? 2 factorial, 2 times 1. All right, now what happens in this thing? All of that cancels. So we end up with n minus 1 over 2. That's all that we have left from this. Would you agree with that?
Does the
Okay.
2 still get the factorial?
Well,
Or does
2
it-
factorial is 2.
Oh, yeah.
So yes, it doesn't matter, but it's easier not to put it in there. All right, now what about this one? Well, first, I'm gonna simplify this right here. When I had to subtract n plus 1 minus 2, I'm going to subtract that, or figure that out, and that's just gonna be n minus 1 factorial, isn't it? So now I have n plus 1 factorial, so that's gonna be n plus 1 times n minus 1, n minus 2, and so on, right? That's my numerator.
Wait, why did you do n minus 1 instead of, like, why did you do negative signs instead of positive signs?
Where?
Like, how did you get n plus 1 and n minus 1 in this?
What does factorial mean?
Going down there?
Go down. So if you have n plus 1 and you take 1 away, what do you have? And then you take another 1 away, they go down. You subtract 1 and you do a factorial, 7, 6, 5, 4, 3. Right? What?
How'd you get n minus 1 from that 9?
What is n plus 1 minus 2? What's plus 1 minus 2? Now, my denominator is gonna be n minus 1, n minus 2, dot, 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 and then my 2 again. That's actually 2 factorial, but 2 factorial is just 2. So everything here cancels. And that fraction, here's the first one. The second one is n plus 1 times n over 2. Now, hopefully, when I add those together, I get this. That's what I'm supposed to be proving. So they have a common denominator. Let's distribute. So what do I end up with after I distribute? These cancel. And I have 2n squareds over 2, which voila is the same as n squared, which is what I was trying to figure out. When you do a factorial, they go down by 1. So we subtract 1 as we go from term to term. All right, and finally, we have an expansion, x minus 3 to the 11th. And we need the coefficient of the x to the 7th term. Now, first of all, would you agree that somewhere on the list there's going to be an x to the 7th? Yeah. We know the first one, if you did the whole thing, the first one would be x to the 11th. And then 10, 9, 8, 7. So it would actually be the 5th term down the line if you had the whole thing all written out. Okay, well, let's suppose I were gonna write the whole thing out. I would start with some basic coefficient numbers, now not the number that's gonna go there ultimately, but the basic coefficients, and where do they come from? Pascal's triangle. Or what did we observe? If I don't want to, this is a big number, kids. I don't really want to build Pascal's triangle that far. You can, absolutely can. What did we notice about those numbers?
We could do the 11C7.
Yes. So, well, be careful with that. 11C11 is the first one, and then 11C10, 11C9, 11C8, 11C7. And we said we did the 5th one, so that is right, 11C7. Now you have to be careful because that will always be the case depending on the order of the problem. But it worked out 11C7 is going to be my coefficient because this term would have x to the 11th, x to the 10th, 9th, 8th, 7th. So this is going to have an x to the 7th. It's also going to have a negative 3 to the what? They got to add up to 11, so it's going to be 4. So I'm going to have an x to the 7th, but the actual coefficient is going to be whatever 11C7 is times negative 3 to the 4th. So 11C7 times 81. So this coefficient is 26,730. So the question said, what is the coefficient? It would be that number right there. All right. So 9-2 homework is due on Friday. 9-2 will be due on Friday. Now, let's get through a little bit of this probability. See if we can straighten some of this out. We've got some vocab here at the beginning. Anybody know what a sample space is? Often when you study data, they're going to say, here's the sample space. You know what that is? It's just all the possible outcomes. So, for example, real simple example. On a true-false question, the sample space is true, false. That's it. If you flip a coin twice, the sample space would be head, 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 tail, tail, head, tail, tail. That's the sample space, because that is all the outcomes, all the possibilities when you flip a coin twice, right? What's the sample space if I roll a die? 1, 2, 3, 4, 5, or 6. The sample space is the actual outcomes. It isn't how many outcomes there are, it is the actual outcomes. Okay, that's the sample space. Sometimes when we do probability, it is easier to write out the sample space to figure out what's going on. Now, sometimes that gets really big, so it's not always the easiest, but sometimes it is the easiest way to examine the problem. All right, what's the difference between probability and odds? Because a lot of people will use those words interchangeably. Anybody know the difference between probability and odds? Because there is a difference to the mathematician. Huh? All right, let's go back to that rolling a die thing. All right, if I roll a die, what's the probability of getting a number less than 3? What's the probability of getting a number less than 3? You all know this.
30%.
Well, starts out as 2/6, and then you reduced it to 1/3, right? Well, let's look at the 2/6. Where did the 2 come from?
Two numbers less than 3.
There are 2 numbers that you want. If you want a number less than 3, there are 2 good outcomes. Where did the 6 come from?
Total number of outcomes.
Total. Probability is the number of successful outcomes. And when we say successful, we mean what you want. These are the things you want over the number of total outcomes. So probability is success over total. True, false question, you guess. Your probability of getting it right is 1/2. Right? Easy. Now, what are odds? Well, odds are the number of successes over the number of failures. So in other words, it's the ratio of what you want to what you don't want. So let's go back to rolling a die, getting a number less than 3. There are 2 successful outcomes, right? How many unsuccessful outcomes are there? 4. So the odds in this situation would be 1 to 2, and that is often written this way, 1 to 2. Odds are often written as a ratio sideways. And what these odds mean are, for every 1 win, there are 2 losses. A probability means 1 win out of a total of 3. These 2 things say exactly the same thing, they just say it differently. Now, let's go back to the true-false question. You're guessing. Your probability of getting it right is 1/2. What are your odds of getting it right? 1 to 1. Those are called even odds. When your chance of getting it right is exactly the same as your chance of getting it wrong, your chance of winning is the same as losing, then it's 1 to 1. That means your probability is 1/2. Right? That's the difference. Okay, so you just want to be careful when you read the question. Obviously, these are the same thing, meaning-wise. You just have to make sure you're answering with the right fraction. All right. Oh, one more definition. A probability distribution. A probability distribution is like down there at the bottom of the page. Each outcome is assigned a probability. So, problem says 2 die are rolled. The probabilities of the sum of the 2 die are listed here. So if you roll two dice, what is the smallest sum you can get? 2. What is the biggest sum you can get? 12. So that's why the sums go from 2 to 12. The number underneath is the probability of that happening. The probability of rolling a 2 is 1 over 36. Because to roll a 2, don't you have to get a 1 and a 1? And if I roll a die, my probability of getting a 1 is 1/6 and 1/6. So that's where the 136 came from. Now, where did the 236 come from? Well, when I roll a die twice, I can get a 2 and a 1, or I can get a 1 and a 2, right? The probability of each of these is 1/36, but it's 1/36 or 1/36, so that's why it's 236, and so on down the line. Okay, so that's a probability distribution. That's just an example down there. Facts about probability. The 2 top ones, the bottom one is kind of a formality, but the 2 top ones are kind of common sense but essential. For every outcome X, the probability of X, that's what that P means, the probability of X will be between 0 and 1. Does that make sense to you? Probabilities are never negative, and they can't be more than 1, so it's somewhere in there. The sum of the probabilities of all the outcomes is 1. So think about it for a second. Does that make sense to you? Something's going to happen. I don't know how many ways it could happen, but it could happen, let's say, 3 ways. If I take the probability of way 1, way 2, and way 3, doesn't that have to add up to 1? Absolutely. Probability it's gonna rain today is 20%. What's the probability it's not gonna rain today? 80%. They gotta add up to 1, all the possibilities. If you look back at your probability distribution here, see all those numbers in the bottom? If you added all those up, guess what happens? The number 1, because nothing else can happen. That describes every possibility. And the sum of the possibilities have to be 100%, right? All right, find the probability of each of the following events. Tossing a head on one toss of a fair coin. 1/2. Yeah, right? 1/2. Tossing 2 heads in a row on 2 tosses of a fair coin. 1/4. Because I'm gonna get a head on my first toss, that's 1/2. And I'm gonna get a head on my second toss, that's another 1/2. And I'm multiplying them because I'm doing both. Drawing a queen from a standard deck of 52 cards. Well, it starts out as 4 over 52, but that does reduce to 1/13. 1/13. What are the odds of drawing a queen? 1 to 12. 1 to 12. Right? Or 4 to 48 if you did it under use. Rolling a sum of 4 on a single roll of 2 fair dice. Now, we actually have the distribution already done for us, but let's pretend we don't. If you are going to roll a sum of 4, what can you get? What can you get?
1 and a 3.
1 and a 3.
3 and 2.
A 3 and a 1, or a 2 and a 2, that's it, right? That's your sample space right there for getting a 4. Now, what's the probability of this outcome? Well, that would be, to get a 1 would be 1/6, and to get a 3 would be 1/6. So that's 1/36. What about this one? 1/36, and what about this one? 136. So what's the probability they're going to get a sum of 4? 3/36 or 1/12. And if you look back at your probability distribution, see where it says 4 and right underneath it is 3/36, that's the probability of getting a 4.
Why would you not have like two sets of like 2 and 2? Because the other guy can also get the other 2.
Okay, but
But it's like, this is
they,
still the
they
same
look
thing.
exactly the same. So think of it as blue and red. So if blue and red are both showing 2, then red and blue doesn't make a difference. Now, blue is 1 and red is 3, that's different than blue 3, red 1, but these two are the same, yeah.
So you said the probability of getting a queen is 4/48,
The odds
the odds.
are 4/48.
Why is it 4/48?
Okay, what are
Because number of
odds?
failures, okay.
Yeah. All right, guessing all 6 numbers in a state lottery that requires you to pick 6 numbers between 1 and 46 inclusive. Okay, we need to guess all 6 numbers in the state lottery. We have to pick 6 numbers, and our options are 1 to 46. All right, anybody have a thought on that one? Now, it's probability, so it's going to be a fraction.
48.
What?
6/48.
6/48?
Yeah, because 1 and 46 are. Oh, sorry, never mind. 46.
6/46? Okay, I'll put that over to the side. I'll tell you what, if that was the probability of winning the lottery, we would have a lot of winners, right? Because that's not very, I mean, that's a huge probability for the lottery, right? So I think we need to rethink that a minute. Catherine?
Is it 146 times 146 6 times?
Okay, let's talk about that. This is getting closer, still not there, but it's getting closer. You guys aren't old enough to play the lottery, but maybe your parents do, or maybe you've seen it on TV or whatever. So, do we have to pick numbers in a particular order to win the lottery?
Yes. Well, it depends which one.
Okay, we're just regular lottery. No, you don't. Remember when they pull the balls out of the thing? That's what we're doing. We're pulling the balls out of the thing. So anytime you do this, Catherine, you're saying first, second, third, fourth. I would not do this problem that way. Furthermore, once I pick a number, I don't pick it again. So when I win a lottery, the numbers are like 2, 3, 18, 41. You don't have repeat balls. So think of that big thing spinning those balls around, and they reach in and pull the ball out, and then they put it on the tray. Once they do that, that ball's out, so you can't have the same number. So those denominators, even if I did set it up that way, those denominators wouldn't all be 46. You see, they would go down. Yeah, George?
46 factorial minus 40 factorial.
Now, George, there's something wrong with that. If I type that in on my calculator, it would be a humongous number. And this is a probability question. So what do I need my answer to look like? I need it to look something. Catherine's was gonna look small. It was gonna be point budded. That's what I need my answer to look like. Okay, I'll take one more guess. Tess?
What number 46 times what number 45 times
Okay, so you're doing exactly what Catherine did, but you didn't listen or it didn't register. Any time that you do this and say, okay, I have 6 picks, 146 chance of getting the first number, 140, anytime you set it up like this, you have inserted order into the problem. You haven't meant to, I mean, it wasn't like a conscious thing, but first pick, second pick, third pick. And you don't have to pick, let's say the winning numbers are 3, 5, 10, 11, 19, 28. Okay, those are the winning numbers. You're telling me I have to pick them in that order, and I don't. So this is not the best way to do it. So I kind of led you, I hope, to be thinking about combinations. Order doesn't matter. How many winning numbers are there? 6. And how many of them do I need to pick? 6. So my numerator is 66. My numerator is what I need to get. I need to get all 6 numbers. Do I care what order I get them in? No, I just need to end up with those numbers. Now, my denominator is the total. How many total numbers are there for me to pick from? And how many am I picking? So my denominator is 46C6. Now, Tess and Catherine, you guys can do the problem like this if you really, really want to. I don't recommend it, because if you do it this way, you have to then multiply by the number of ways those things can be arranged, which is 6 factorial. So you can do it that way, but you have to accommodate all of the arrangements then. Okay? So this should be a really small number, George. I got times 10 to the negative 7th.
Yeah.
Okay, that's pretty small, right? Somebody wins sometimes, but the odds aren't in your favor for sure. All right, that was a good exercise for us to talk about in terms of how we're going to structure our problem and
How would you write the probability?
well, you'd have to write it as the decimal. So you would have to write it as, I don't know if it will math correct, will it? So you're just gonna have to say 1.0676 times 10 to the negative 7. Yeah. Find the probability of rolling a sum divisible by 3 on a single roll of 2 fair dice. Find the probability of rolling a sum divisible by 3 on a single roll of 2 fair dice. Okay. What would I have to do to get a sum divisible by 3? My sum would have to be either 3 or 6 or 9 or 12. Would you agree with that? Okay, so I'm gonna roll 2 dice. I gotta get a 3. I'm either gonna do a 1 and a 2 or a 2 and a 1. Would you agree with that? So that's how many ways to get a 3. All right, what about a 6? 1, 5, 5, 1, 3, 2, 2, 3. Or no, 2, 3, 3, 2, 4, 4, 2. Did I get them all right this time? Let's see, is that it for a 6? Yeah. 9 would be 5, 4, 4, 5, 6, 3, 3, 6. Is that it for a 9? And then a 12 is just 6, 6. Guess what I'm doing right here? What do I call that? It's a sample space. This is all the possibilities. Those are the only ways that I can get what I want. How many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12? Now, I'm not going to write out all of them, the total. I want you to think about it. How many ways can the first die land? 6. How about the second one? So how many ways can they land together? 6 and 6 would be 36. So the answer is 130. Guys, there are 36 total outcomes when you roll 2 dice. If you don't believe me, write them all out. I did the sum being 3, 6, 9, or 12. You would have to do all of them. There they are. Oh, is that our probability? Oh, let's go back. The probability of a 3 is 236. A 6 is 536. A 9 is 436. And a 12 is 136. The sum of those is 1236. Is it possible to weight a standard 6-sided die, so just a regular little cube? Sometimes the bad guys weight the die, so that changes the probability, right? So that would be like illegal, but some people do it. Is it possible to weight a standard die so that the probability of rolling each number n is exactly 1 over n squared plus 1? All right, let's talk about that. Each number n. All right, so what's the probability of rolling a 1? The probability of rolling a 1 would be 1/2. 1 squared is 1, 1/2. How about a 2? What's the probability of rolling a 2? 1/5. How about a 3? 1/10. 4. 5. 6. Did I do my arithmetic right? Now, when I roll a die, is there anything else that could happen? I'm gonna get a 1, 2, 3, 4, 5, or 6. Is there any other option? No. So therefore, what do all these have to add up to? 1, 100%. They have to add up to 1. If it's possible to do this, they're going to add up to 1. What do they add up to? I got 0.92.
Yeah.
Is that what you got? So is it possible?
Nope.
No. Because you can't have mutually exclusive events whose probabilities do not add up to 1. Because every base has to be covered 100%.
How do they weigh the die?
Well, they just put a little weight inside of it. They somehow cut it open.
And how does that make a difference if it's just heavier?
Well, if it's heavier,
if you
it'll
put it-
naturally fall down.
Like if you put it in the bottom of like the 1, like, or like at the top.
There's like a way to put it, like,
Like-
a lot of engineering.
Think about like,
Maybe they like inject it
like
with
think about
it.
now.
All right, a couple more. George? Okay, so let's think of it like this. Let's think of it like this. If there are, let's say everybody goes out of the room except 4 people, all right? There's 4 people in the room, okay? That's all that's left, 4 people. And I'm gonna pick somebody, just randomly. So the probability that I would pick her is 1/4. Would you agree with that? And the probability that I would pick her is another, why aren't you in uniform, by the way?
Oh, maybe someone.
Oh, good luck. What's the, probability I'd pick her 1/4 and her 1/4 and her 1/4, right? So the total probability, every possible occurrence, 1/4, 1/4, 1/4, 1/4. Now, they don't always have to be equal, they are in this case, but they have to add up to 1. It's how we can say, we're gonna use some tree diagrams, and if I say the probability that Sid will do her homework is 9/10, then I automatically know what? The probability she doesn't do her homework is 1/10. They gotta add up to 1. All right, next problem. Here we go. Sal opens a box of a dozen chocolate creams and generously offers 2 of them to Val. Val likes vanilla the best, but all the chocolates look alike. If 4 of the 12 are vanilla, what is the probability that both of Val's picks turn out to be vanilla? Okay, so it's probability, so it's a fraction again. On the top goes what we want. Okay, so what do we want? We want 2 vanillas. Well, how many vanillas are there? And I need to pick 2 of them. There's my numerator, right? I'm using C because clearly the order doesn't matter. Val wants to end up with 2 vanilla candies. Now, what goes in the bottom? The total. How many total candies are there? 12. And how many is she picking? 2. So your denominator is 12C2. This one probably will math crack. I would prefer you not round off decimals, if you can help it. If they don't math frac, then they don't really have a choice. Did you get 111? By the way, your calculator will do this all at once. You don't have to do it separately. 4C2 divided by 12C2, it will do that. You don't need parentheses or anything like that. One more problem and we're out of here. All right, using a Venn diagram, we have a large high school. And we know that 54% are girls and 62% are sports, and that's 62% of everybody. Half of the girls play sports. I don't know how to write this, okay. All right. What percentage of the students who play sports are boys? Well, let's think about this. Here is the box of all the students in the school. And since these are percentages, I'm just gonna say there's 100 of them in there. There could be any number, but 100 makes it simple with percentages, right? And some of the people in here are girls. And some of the people in here play sports. And some of them do both, are girls and sports. Would you agree with that? Now, how many people, with 100 people total, how many are in the entire girl circle? 54. But half of those also do sports. So I'm gonna split that 54 like this. Would you agree with that? Now, how many people altogether are in the sports mall? 62, but I've already counted 27 of them. So how many are left over here? 35? Now, what are these 35?
Boys.
These are boys, I should say, not girls, who play sports. So wouldn't that be boys who play sports? Now, wait a second. 54 and 35, that adds up to, what is that? 89? So what are these 11 out here?
Boys who don't play.
Boys who don't play sports. Does that make sense to you? If you're outside the G ball, anywhere outside the G ball, you're a boy. 35 of them play sports, that's 25%. And 11% teacher. Wait. If a student is chosen at random, what is the probability that it is a boy who does not play sports? 11 over 100, right? 11%. 11% of the boys don't play sports. 11% of people. All right. See you tomorrow for another fun-filled. What are you typing in there, Austin?